So without further ado, we can start the session. Okay. Yeah. So let me just give you a quick glimpse about what is machine learning versus deep learning. So learning, we all know that we actually started learning from our mother's womb itself. And we even day-to-day basis, we also learn whatever we see in around us. So we acquire some knowledge and we use that knowledge to recognize something, to predict something, to forecast something, etc. So these problems are basically the learning problems. Now what is machine learning and what is deep learning? So all this machine learning and deep learning come under a unified set that is called artificial intelligence. So artificial intelligence is the higher set. So if I draw it over here, 1 second. So if I draw it over here, so this could be AI.
So please share your screen, please.
It is not visible, sir.
Share
Oh,
your screen.
yeah. There was some issue. Yeah, so I think the screen is visible right now.
Yes, sir.
Ah,
Yes, sir.
yes,
Yeah,
sir.
yeah.
Thank you. Thank you.
Okay. So what I was talking about, I will give you a quick glimpse about the week's content. Then followed by that, we'll solve some questions that, for example, week 0 is there. Week 0 is already evaluated, and week 0 marks will not basically affect your final gradings. So it is just a dry session. So week 0 quiz will solve, and along with that, I will solve some week 1 practice questions, which is similar to the questions that you can find
So
in
your
the
voice is breaking.
voice is breaking. Can you hear me? Hello?
We can
Yes,
hear
sir.
you.
It is
Yes, sir.
clear.
Yes, sir, we
Okay.
can
Yes, sir.
hear
It
you.
is
Okay.
clear.
Okay. Probably at your side, some network issue is there. At my side, I think
Yeah,
it's
you are
fine.
audible actually.
Yeah. Okay. Uh, so as far as learning is concerned, we are learning day-to-day basis, and we use those learning to do certain tasks. For example, recognizing something, forecasting something, predicting something, etc. So these all learning things basically comes under a bigger umbrella, which is basically the artificial intelligence. And in artificial intelligence, so this is AI. And in artificial intelligence, there is a subset called machine learning, and there is some special learning mechanisms are there, which is basically a subset of machine learning, that is deep learning. So what are machine learning and deep learning? So for example, we want to classify a large scale of images. For example, you have been given 10 millions of images, and manually classifying these images are very much it's pretty impossible. You cannot hire someone to classify 10 millions of images. So why can't we use machines? Why can't we train the machines in such a way so they can get some intelligence out of the training images, and then the machine itself will give some predictions. So for that, people started using some feature extraction. So for example, you've been asked to do a cat or dog classification. So in case of cat or dog, what we'll do, you have an image of cat, you have an image of dog. Now you extract some features. So features we already have seen in the classes. So we extract some features. So for example, here, okay. For example, in case of cat, you can generate feature of height for both cat and dog class. Then you can take the feature, for example, length of the tongue, so LT, followed by the texture information. For example, this is texture information, and similar features like this. And you can encode all these features into a vector V. for both cat. So you will have for cat one array and you will have dog array. And then you feed your machine learning models. So this is a ML model to give the classes. So given this particular feature vector, you will map it to either cat, and given this particular feature vector of dog, you will try to map it to dog. Now, learn after training this particular machine learning model, now your model will be able to predict, given a particular feature vector, whether the feature vector is coming from a cat class or it is coming from a dog class. For example, similarly, over here, my research area is biomedical signal processing and deep learning. So many a times I will be referring some biomedical examples. For example, this time domain, these are two time domain signals. This is called heart sound signal, heart sound. So this heart sound can be heard using these stethoscopes. So this is a normal heart sound signal. This signal is called S1, this signal is called S2. So this is normal. And this is a abnormal case. So let me label it as abnormal. Okay. Now, if you try to classify, given this particular signal and this particular signal, if you try to classify whether the signal is normal signal or abnormal signal. So first, likewise, you have to extract some features. For example, from here, we are extracting features such as entropy. Then, for example, by looking to the signal itself, we can see that there is some extra component in the abnormal part. That means if I calculate the energy of the signal, obviously energy will be higher for this particular signal, whereas energy will be lower for this particular signal. So I can take another feature, that is energy. Similarly, we can extract several features from both the signals, and then we can train a machine learning model, and the machine learning model will give you the classification results. So this is as far as what machine learning is concerned. In case of machine learning, we will be focusing on this handcrafted feature extraction. This is very much important. Any machine learning model needs a handcrafted feature extraction part. That is why actually in the first few lectures, sir was actually discussing the different types of features, for example, boundary features, region based features. So you need to extract some features to classify your images, whether it is a dog cat image, whether you have signals. So you need to do good, you need to extract good set of features. And why you need to extract good set of features, that I will tell you right now. For example, I think someone's mic is turned on. You can unmute yourself. Please let me see. Okay. Yes. So over here, you can see that we have two classes. We need to classify two classes. So can anybody comment about these two images? Are these two same class or something different is there? Or they look alike?
Noise is there, right? Intensity of color. Noise.
No, as don't consider noise and all. Just see the images.
Intensity of color.
No, 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 no. Just in terms of the object that is present, are these objects are looking same or something different is there? For example, we have cat and dog class over here. So are these two looking alike? The objects present in the
Yes, yes.
Yes, they are alike.
they are
Yes.
alike.
They are
Now, yeah, they look alike. Now the problem becomes challenging when you need to when you will be asked to classify these two images as because they are actually different. This is an Enold and this is a red bug. Now, for
So
example,
we are
in case of
extracting
yeah,
features with the horns, right? Like that
yeah,
is one
for
of the features.
example, over here, in case of machine learning model, the classification task was quite simple because you have two different classes and there was quite variability in these two classes. For example, obviously, the texture feature in the cat will be so different from the texture features from the dog class. So over there, you are very much confident about whatever feature I was extracting. That was very much helpful for classification. Now, when the problem becomes so difficult, for example, it seems to be these two images are coming from same classes, but they are actually different. Now, how can you ensure that whatever feature you are extracting, that will give you very good classification? Now, in case of these types of problem, the feature extraction process or handcrafted feature extraction process becomes very difficult because uh, the handcrafted feature extraction parts becomes very difficult because they look almost alike. So whatever feature you will extract from these two images, they will also become quite alike. And for example, uh, if you feed those features to a model, your model accuracy will automatically degrade because features are alike. So if the features are not quite distinguishable from each other, then you cannot classify it very well. So for these problems, people started exploring the field of deep learning. In case of deep learning, what people basically argued that what people actually argued that is you feed this image directly to the model and let the model learn the features by itself. And it has been seen that by doing this all feature extraction process at an automated fashion, the model learns very well features which are quite discriminative. And if the features that is basically learned are quite discriminative, your model accuracy will also go up. So over here, in case of deep learning, there is no further uh, processing steps such as handcrafted feature extraction, as the machine itself tries to learn to extract good features, which has the class separability information, so that the classification accuracy will go up. Similarly, for this particular case, these signals look alike, but these signals are coming from two different cases. This is called lung sound signal, and this is a signal from healthy person, and this is a signal from asthmatic person. So over here, you can see that these signals are quite similar. So whatever feature you are calculating over there in case of this particular classification task where there was clear cut information gap is there. For example, this is quite smooth. Over here, the energy is higher. However, over here, the lung sound signal for healthy and asthmatic, they look quite same. So your machine learning model have a hard time will have a very hard time to classify these particular cases. So people started exploring deep learning for these particular difficult classification tasks where the feature that you extract becomes quite alike with each other and the model, and then thus the model performance will go down. So deep learning will try to extract features by itself and then it will try to classify. So this is the basic difference between machine learning and deep learning, and our this particular course is basically focused on deep learning. So in the first week itself or first few weeks, 2 to 3 weeks, we'll be talking about basic machine learning models such as SVM, multi-class SVM, etc. And followed by that, we'll be totally shifting our focus onto various deep learning models. For example, convolutional neural networks, autoencoder, etc. So this is the very high level glimpse that what is basically meant by machine learning and deep learning. And the main difference is that machine learning incorporates handcrafted feature extraction. Deep learning does it by itself. Okay. So as far as the region descriptor, boundary region descriptor and the boundary level descriptor, so we'll be solving several problems, and through problems we'll try to address some of the theoretical queries. And as far as the classifier is being concerned, so let me just give you a quick glimpse of the classifiers. For example, minimum error classifier, they basically use the Bayes rule. So for example, this is a feature space and you have two classes, bird and dog. So for example, you have extracted two features from two classes and they look like this in the feature space. This is, let's say, x2, x2, and this is x1. So given this x1 and x2 features, the class looks like this. And if you try to enclose these classes into a boundary, so you can see that these are having some kind of circular or elliptic shape. I don't know, people are trying to join, whether they are automatically getting into the meeting or what. Okay. So over here, you have two classes and two features, and the feature space looks like this. Now, given these two features, you will see that at the centroid, someone's mic is on. So please turn it off. So over here at the centroid, the density of the feature is high, and if you go around from the centroid in the outer direction, you will see that the feature intensity will be smeared down. So over that means we have some sort of distribution. For example, a distribution like this. At the centroid, you will have very high intensity, and if you go go away from the centroid, so at both direction you may be having some smearing effect or lesser intensity effect. So this is called the class conditional probability. That means given a particular class omega, you have extracted some features, and these features can be represented by some distribution. And at the same time, for each of the class, you may have some initial prior experience. So this called actually the prior probability. So prior probability means for a particular class, you know some already information is given to you. That means you have some abundant information of that. So from there we can extract the prior probability, and this is called the class conditional probability. Now, if I consider a joint probability P of x comma omega, so the joint probability, from the probability rule, we can write it as x given omega, P omega, and P of omega given x and P of x. So if I just solve the this particular equation, so it will be x given of omega, P of omega, and P of x. So in case of classification, let's say you have two classes, so it will be omega 1 given x, P of x given omega 1 and P of omega 1, and divided by x, and P of omega 2 given x is x given omega 2, P of omega 2, and P of x. Now you can see this term in the denominator, they are actually the same term. So you can just ignore this particular term. So if you want to classify a feature into class omega 1, then your probability of omega 1 given x should be greater than probability of omega 2 given x. So this is the basic logic. If the a posteriori probability is higher for a particular class, we'll say that that particular feature basically belongs to that class. if we are saying x belongs to omega 1, then it has to obey this particular rule that our a posteriori probability of omega 1 will be greater than a posteriori probability of omega 2. Now still, if I draw the a posteriori probability, for example, this is the a posteriori probability for p of omega 1 given x, and this is another a posteriori probability p of omega 2 given x. Now, can anyone of you answer that I have a feature, let's say, and the feature location is this. So x belongs to which class? Omega 1 or omega 2?
It's not clear. It can be in X, omega 1 or
Yes. So at this particular condition, your answer is you are right. So technically you can say that can't be decided as because the probability values for both the classes are same. So over here they have an intersection, that means p of omega 1 over here what is happening, p of omega 1 given x is equals to p of omega 2 given x. Therefore we cannot decide that which particular class it is belonging to. Now if I have a feature over here, let's say this is x naught over here. So it belongs to which class?
Omega 1.
No, not omega 1.
2.
Yeah, it is omega 2, and omega 2, if I just draw the sorry, it should be a line, but okay. So this is the probability value for class omega 2, and this is the probability value for class omega 1. So clearly we can see that p omega 2 is higher. That means it will be belonging to this particular class omega 2. And what is the error?
Omega 1.
The error is
Probability
the
of one omega 1.
yeah. Probability of omega 1 given x, as because total probability is 1, and your correct classification probability is omega 2 given x. So incorrect or error is equals to 1 minus p of omega 2 given x. So 1 minus p of omega 2 given x will give you p of omega 1 given x, as because total probability is equal to 1. So therefore error is p of omega 1 given x, or mathematically saying it is minimum of these two a posteriori probabilities, p of omega 1 given x comma p of omega 2 given x. So over here we can say that p of omega 1 given x is smaller, so your error will be omega 1 given x. So these are different views of the problem, so you can solve from any of the angle. So these are different illustrations for that. Now another classifier is there, that is Bayesian risk classifier. So can anyone difference between error classifier and this particular risk classifier? What is the difference between these two?
It has a error function uh, in the risk classifier, and it also has a threshold by a way of error function.
Okay, so partly true. For example, we actually try to incorporate a term risk. That means uh, we we consider that for each and every for each and every prediction we make, for example, for x belongs to omega 1 or omega 2, if I predict omega 1 is the actual true state, then we have a corresponding risk associated with that, and we try to minimize that risk, and for whichever class the risk is minimum, we'll consider that the feature is belonging to that particular class. For example, omega 1 and omega 2, let us consider omega 1 belongs to benign tumor. Benign means a normal tumor. And omega 2 is a malignant. Malignant is the cancerous tumor. Now, let's say if a tumor is omega 2 and your model predicts that actual true class is omega 2, but your model predicts that your feature belongs to omega 1. That means you are doing some misclassification. And the misclassification will be so serious. For example, if person is cancerous, you are predicting that, okay, no, the person is not cancerous. He is quite fine. So the consequence will be very much fatal. So to avoid this kind of situation, we have incorporated a risk term. So this is the actually physical significance that why incorporating a risk term. Bayesian minimum risk classifier was fine, but for to avoid these particular cases, for example, you are misclassifying this as normal tumor, then your risk will be very much high. But we want to mitigate those risks by incorporating the loss functions and risk terms associated with that. So in case of Bayesian minimum risk classifier, let us consider we have classes omega 1 and omega 2. You can even generalize it for C number of classes, but over here I am considering 2 classes and 2 actions. If you choose it to be of omega 1, then you will take action alpha 1 and you will take action alpha 2 if the class is omega 2. For example, if the class is cancer, then alpha 2 will be operation, and if alpha class is normal, then your alpha will be you don't have to go for any chemotherapy or operation. So we also incorporate loss function or penalty factor. We call it a penalty factor. For example, you take alpha I action. You take alpha I action when the true state is class J. Then you actually incur some amount of losses. For example, your true class is 2. That means your true class is cancer, but you are taking action for a normal class. That means you are doing some sort of misclassification. And this misclassification for this particular case, the penalty will be very high because the person may die also because of your misclassification. So over here, the penalty will be very high. But however, if you take correct action for a correct class, that means you are taking the true state is 2, that means cancer, and you are also taking action for the cancer class. That means you are telling that patient to go for a chemotherapy. So that means you are doing good job. So over here, the penalty will be low as because you are doing correct classification. So risk is what alpha I given x, we can write it as P of omega j given x and corresponding lambda ij. So I am writing lambda alpha I omega j as lambda ij to simplify it. And then if I say x belongs to omega 1, then alpha 1 given x will be P lambda 1 P of omega 1 given x and lambda 1 2 P of omega 2 given x. And similarly, you do it for alpha 2 given x and you will get the similar expression. So if you say that x belongs to omega 1, then your risk alpha 1 given x should be minimum, isn't it? This is for predicting class 2 and this is for predicting class 1, and we are trying to minimize the risk. Therefore, this risk value for omega 1 should be minimum and the risk value for class 2 prediction will be higher. And if this is so, then we can say that, okay, X belongs to class omega 1. And the relation that describes this particular case is if you solve this inequality, so you will get P of omega 1 given X divided by P of omega 2 given X is greater than lambda 1 to lambda 2 2 and then lambda 2 1 and lambda 1 1. So this you can do it by yourself. Just you have to plug this particular equation, and likewise you just have to solve this equation inequality, and then you can get down to this particular relation. Okay, so this is a quick glimpse
And
of yeah.
so there is a query, sir. The
Yes.
value of P of omega 2 given X will be equal to 1 minus P of omega 1 given X.
Value of
Uh,
P of omega 2
given
given
X
X.
will be equal to 1 minus P of omega 1 given X. Am I correct or am I in confusion somewhat?
No, this is correct. As far as you are working with, for example, this kind of probabilistic view. So this is correct. For example, total probability is how much? Total probability is 2. Total probability is 1, sorry. And you have 2 classes. So you will have probability associated with class 1 as well as probability associated with class 2. So if you add these two, so your total probability will be 1. So P of omega 2 given X will be 1 minus P of omega 2 given omega 1 given X.
And sir,
And
P of omega 2. P of omega 2 will be 1 minus P of omega 1.
yeah.
Is it?
Yeah.
It will also be correct.
Yes. For example, let me write it. P omega 1 given X, P omega 2 given X equals to 1. So from this particular equation, you can get the answer. Okay.
So in assignment, there's the question. So I can get the value of P of omega 1 given X as the value of P of omega 1 is given. But I am not given the P of omega 2 value. And I have to calculate the risk base risk classifier. So
Are you talking about quiz 1 question number 9?
sir, I'm talking about quiz 1. No, sir. Assignment 1, question number 2.
Question number 2.
So
Actually,
assignment 1.
I haven't seen the questions that is there, but what you can do is just put this particular query in the forum. So there is a forum in the course website. Ask a question.
Okay,
You
okay, sir.
write this. You write your query over here, because today I didn't get time to see what is there in the live quiz. So if there is any discrepancy in the question, so we'll correct this particular question.
Okay, sir. Thank you, sir.
Okay,
Thank you so much.
actually, even I haven't checked also, so I cannot make any comment on the question. So today I will check, and then if it seems that
Actually,
there
I'm
is
in
any
the
problem.
confusion that I have to calculate P of omega 2 with the help of P of omega 1, or I have to calculate P of omega 2 by X given X with the help of P of omega 1 given X.
Actually,
Uh,
I also
okay,
have to
sir.
see the
No worries.
question.
I will put in the forum. Yeah. Thank you, sir. Thank you.
You put
Okay.
the
Thank
question
you.
in the forum. We'll try to check the
Thank you, sir. Thank you.
possibilities.
Yes, sir,
Okay.
one question. If you can,
Yes.
if you could go
Can
back,
you please repeat the risk factor?
Yeah.
you could go back to the previous slide and
This one.
yeah, this one. And on
Yes.
the second line, we are saying lambda alpha I given wj into lambda ij. So, is there any specific reason why we are looking at omega j here?
Okay. So as I have already said that, for example, you are having a real life problem. Let's say you want to classify a benign tumor or malignant tumor. So there could be 4 different cases. Uh, one could be you are taking actions, because in case of minimum risk classifier, we have incorporated another term, that is what action. So you will be having action 1 and action 2. So there could be total 4 cases. What are these cases? One case will be you are taking action 1 given you are the actual class is omega 1. So that means you are taking action 1. That means you are asking the patient, okay, you are fine. You don't have to go for any chemotherapy. And actual class is also omega 1. So that means you are doing very good classification. That means your penalty is very low. So this is a first case, lambda. That means penalty for this particular action taking, it will be very less. Second case could be your class is omega 1, true class is omega 1. And you are asking the patient, okay, we are taking the second action. That means you go for chemotherapy. That means you are asking a normal patient to go for a chemotherapy. That means this is a penalty for that particular classification. Third would be your true class is omega 2, let's say, and you are taking an action omega 1. So it implies that a person is having cancer, and you are asking that, you are saying that, okay, I am predicting you as a normal patient. So you don't have to go for chemotherapy. That means over here you have very high penalty. And last option will be omega, over here I'm writing. So lambda alpha 2 omega 2. That means your true class is omega 2 cancer, and you are taking a action which is go for chemotherapy. So for this particular action, the penalty will be very less. So given these actions you take corresponding to any of these classes will introduce some sort of penalty factors. If you are taking the same action from which the class is coming, then your penalty will be very low. And if you are doing the other way around, then your penalty will be very high. So therefore, we are talking about this particular term lambda ij. If you take any certain amount of action, so for that action, you will have some kind of penalty. If you take some opposite actions, that means your penalty will be high. And if you take the similar actions from which the class is coming, then penalty will be low. I hope this answers the question.
Sir, I think that helps. And is my question is that the same reason why we are multiplying the class probability of omega j given x with the
Yeah.
penalty factor?
Yes, yes, yes. So this line has also a physical meaning. So you are true. You are saying correct thing. So over here, let's say you are taking lambda 1 1 action. Means the penalty is lambda 1 1. That means you are taking uh, uh, action 1, and your true class is also omega 1. That is the first. That is the normal class, and this is the a posteriori probability for that. And there is another condition that would be your original, let's say your original class is 2 and you are predicting it as 1. So here you are doing some sort of misclassification and you are multiplying with the corresponding a posteriori probability. So this risk is basically an average risk. So it is not basically for this particular, you take one action, you take the you compute the risk for that particular class. Rather, it's an average operation. So you consider all the possible all the possibilities by which you can consider the risk evaluation. So this is a kind of expectation value, expectation. For example, we write in case of probability, we write Ex is equals to x into Px. This is probability. So similarly, we are trying to get some average information across all the available probability of classification, be it an a posteriori probability and be it the penalty factor associated with that.
Thank you.
Okay, so with this, we can start solving the question. So I know these questions are very easy, but still as per the guidelines, we need to solve the question. So x cube ln x, so it will be 3x square and ln x, and then you take ln's derivative, so it will be 1 upon x and x cube, so it will be x square plus 3x square ln of x. So over here option B. So I think I can go quick with this these kinds of questions. So
Excuse me,
few
sir.
of the yeah.
Sorry for interrupting. I just had two general doubts.
Yes.
So are we supposed to attend all of these problem solving sessions?
It
Three
is
of them.
it is actually not mandatory. So what we will do from our side is while giving the lecture, we are recording the lecture simultaneously. So as per the PMRF guidelines and NPTEL guidelines, we'll be uploading these recorded sessions in our respective YouTube channels. So I will be uploading this particular video by today itself. I will upload this video in YouTube. So if you are not able to join this class, so later on you can check the video. When
Okay,
you
so
are available, as per your availability, you can check the video. So it is not
so
mandatory.
so will we, okay. So will we be given a link of the YouTube
Yeah.
video that you?
Yes. Actually, in the website, actually today is the first live session. So you will see in the website over here, there will be another tab that is on the name of problem solving session. So you click the problem solving session, it will redirect to a Google Sheet. Over there, you will see two TAs, name of two TAs, and under which whatever recordings they have created. So we'll be uploading our YouTube video links over there, and you can just access those videos from there.
Okay. And like in all three sessions, you'll be doing different problems.
Uh, for example, what I have planned to do, one question I will raise to like you participants can give me some suggestion. For example, there are two TAs for this particular course, me and another guy from IISc. So we'll be discussing the questions that is mandatory, and I personally thought that this particular course is something which you will be implementing it by yourself, because theoretical knowledge is not sufficient to implement this particular whatever you are learning over there. So you need to implement it in real time. So for that, I will be using some hands-on sessions also. We'll be doing some Python codings. So uh, I thought that in initial some of the couple of lectures we'll do some hands-on session, and then in the next week session we'll do the problem solving session only. So uh, I need some of your opinions that what will be the flow, because uh, I think implementation of these particular lessons that we are learning is quite important as far as if someone is trying to do research on this particular area. So implementation is also an important thing. So do you want Python implementation, or I will, or if you don't want, then I will skip that part.
I think, sir, looking at the implementation, going through that would really be very helpful.
It would be very helpful if you could take us through Python as well.
Okay, so what I will plan is that, for example, today for this first class, I was describing the theoretical part, basically the glimpse of the week one. So from the next week, I will omit that part. If you have any particular query, what you will do, you put that particular query in the forum. Then depending on the questions that is being raised in the forum, I will try to give quite justification for those particular questions that you are asking. And then I will directly go to the problem solving, and followed by that will do the coding sessions. So it will so we'll be utilizing the time accordingly. Otherwise, what will happen is that if I start describing the recap of the lectures, so it will substantially kill time. So it will be better that we'll be focusing on directly to the questions, problems, and then we'll go for the coding sessions.
The coding sessions, I think, would be really helpful, as others pointed out. I agree with
Yes,
that.
yes, yes. But we also have to do the question answer solving session also, because as far as exam is concerned, there will be no coding questions. You need to solve the mathematical questions over there. So I will try to make a blend of both question answer and coding, because for example, in this particular week, we can do the coding session for the next couple of 2 or 3 weeks. So there is no that much necessity to go for the coding session, because basically they are machine learning models. So you will not be developing machine learning models by scratch. You will be using some standard libraries. So over there, I can skip some coding classes. But in this particular class, the feature extraction and all these things, I thought of showing the codes. So from the next week, I will omit that recap part of the week's content and directly go to problems, and then directly go to the coding sessions. I think it will be fine.
Sir, one more question.
Yes,
In the
yes.
exam, do we have to remember all these formulas, or how is
Uh,
the exam pattern?
Uh, exam
Yes, sir.
pattern till date, so they have not announced anything with the PMRF TAs, but again, you can raise the question there. Some TAs of the professor PKB, they will be there also. They will answer the question. Otherwise, what is my experience? This is the second time I'm taking the NPTEL PMRF TA. So last year was you have to memorize the equations, because you'll be dealing with the numerical answer type questions and MCQ questions. That is the for example, what are there in the live quizzes. So you'll be given some problem statements, and then you'll be asked to find this particular value, that particular value. So to solve those particular questions, you need to remember the equations. So that is there. So MCQ questions will be there, and as well as the NAT numerical answer type questions will also be there. For example, a dash is there, you need to put the values, and with a precision of 2 decimal points or 3 decimal points given as per the question. So this is the basic structure of the exam. So there, I think there will be no essay type questions, only MCQ, MSQ, multiple select question, as well as the NAT type question, numerical answer type questions. So these 3 types of questions will be there, and for that you need to do the mathematical work.
Okay.
Okay. Okay, so let's proceed to the next question. That is, uh, uh, you have been given a function sigma x of this sort. So can anybody tell me that this function is named as what?
Point. This is sigmoid.
This is sigmoid function. And the shape, how does it look like?
It's horizontal S.
Yeah, horizontal S. So at 0, it will be 0.5. And as you go to the negative side, it will reach 0 at infinity. And as you go on in the positive side, pardon my drawing because I'm not able to draw properly. So over here, it will reach 1 at infinity. So these curves are called asymptotic curve. Asymptotic curve means at infinite, they will be reaching to a particular value, either 0 or 1. Okay. So if you take the derivative of that, so it will be sigma dash of x is equals to 1 plus e to the power minus x ka whole square, then it will be 1 plus e to the power minus x multiplied with 0 minus then 1 and 0 plus e to the power minus x into minus 1. Fine. So it will be e to the power minus x 1 plus e to the power minus x multiplied with 1 plus e to the power minus x. So 1 plus e to the power minus x is what? Sigma x. And I can write this particular thing as 1 minus e to the power minus x 1 plus, sorry, I can rewrite as 1 minus 1 by this. So this is what? 1 minus sigma x. So the final answer will be sigma dash of x, or derivative of sigma x is sigma x multiplied with 1 minus sigma x. So this is the final answer. And this is the option C. Okay. So can anybody answer this particular question? This is kind of easy question. So there are total 5 and 7, 5 black balls and 7 white balls. We assume we have drawn 2 balls randomly 1 by 1 without any replacement. And what will be the probability of both balls are black? So can anybody answer this particular question? So how we'll proceed that, let's say first ball to be black is equals to, you have 5 black balls out of 5 plus 7. So it will be 5 upon 12. And now you have plugged out one black ball. So in the second case, you are left with 4 black balls. So it will be 4 plus 7. So 4 divided by 11. I think someone is trying to join. 4 divided by 11, and this is, let's say, P of B event, and this is P of A event, and P of AB is equals to P of A, as because independently you are doing this particular operation. So it will be 5 upon 12 multiplied with 4 upon 11. So this will be 20 upon 132. Okay. Excuse me, I think someone's mic is on, so you can turn it off. So for this particular question, what will be the answer and what will be the approach actually? Answer to we all know is because the solution has been given. So what will be the approach? Anyone? So the question states that a bag contains 2 red, 3 green and 2 blue balls, and 2 balls are drawn at random. So then what is the probability that none of the balls drawn is blue? So we have total balls is equals to 2 plus 3 plus 2, that is 7. And the first operation, so the total sample space will be 7C2, as because we are drawing 2 balls out of this 7 pool of balls. And the event is, so if I annotate it as S, and the current event is 2 ball will be drawn, and accordingly none are blue. None are blue. So at this particular condition, it will be how much? Anyone? If none of the balls are blue, then what will be the probability of that particular event?
5C2.
Yeah, so this will be 5C2, and the whole probability will be, so the p value will be 5C2 upon 7C2, as the sample space is 7C2. Okay, so you can evaluate it and get the final result. Okay. So here the question is in the next question. So what is the probability of getting sum 9 when two dice are thrown? So two dice are thrown. So what will be the total sample space? How many samples we'll get if we throw two die?
36.
36. Yes.
36.
Yeah. And the corresponding events will be 3, 6 to get sum 9, then 4, 5, then 5, 4, and then what you call 6, 3.
4 by 36.
Yeah. So the probability will be 4 by 36, and it will come down to 1/9. Okay. So next question is area under the standard normal curve. So can anybody tell me which one is a standard normal curve? I am drawing two curves. Sorry.
Second one is normal.
So let's say this is 1 and this is 2. So which one is standard
Second one.
normal?
Second
Yeah,
one is normal.
second one is standard normal, not just normal. So normal distribution, for example, X belongs to normal distribution. Normal distribution is parameterized by two moments, statistical moments. They are sigma, they are mu and sigma. So this is the mu or the mean, and this is basically the spread of the
Variance.
distribution, that is sigma. So over here you can see that mu and sigma can lie at any particular position, because the mu can be different, sigma can be different for different classes. So this is called the general or simplified normal distribution. Now, what is the meaning of standard distribution? Standard distribution comes from x in 0, 1. That means over here the peak should be over here at 0, but drawing is looking something else. So the mean will be located at 0, and this particular spread, will be 1. And this basically ensured by a normalization that is called z-score normalization. So we given this particular PDF, we do a operation like this: x minus mu divided by sigma. For example, at this particular position, initially mu was over here. Now, in case of z, mu minus mu divided by sigma is equals to 0. That means this mu point will be shifted to this 0 point. So over here, the mean is located at 0 position. That means this curve is called normal distribution and this is called standard normal distribution. And this normalization operation, it is called z-score normalization. This is very important normalization. You will get to know about this very well in the course. This is called z-score normalization, and it helps in several manner. For example, one phenomena is there that is called covariate shift. It will help to reduce the covariate shift of any deep learning model. So that will be discussed. But as far as the question is concerned, we know that the area under the curve is equals to area under any PDF is equals to total probability. Total probability. And total probability of any distribution is what? 1. So over there the answer will be 1, as because total probability is equals to 1. Probability cannot go beyond 1. Okay. So the next question is x1, x2 have been given, two vectors have been given, and there is a set of vectors x1, x2 and x3, and it is told that they are linearly independent. So you need to search for the value of x3. So has anybody tried this particular questions by themselves and got it correct?
Yes, sir.
So what is your approach? Yes. So if anyone has tried this particular question, so how to solve this particular question? Okay, so let me solve this particular question then. So theoretically, let's say if you have a set of vectors v1, v2 and v3, they will be called linearly independent only when a1 into v1 plus a is scalar, a2 into v2 and a3 into v3 is equals to 0 only when a1, a2, a3 all are 0. This is the condition. So this seems to be very much mathematical, and it seems to be there is no physical interpretation of this particular sort. But you can physically interpret these kind of problems. For example, you have a vector, let's say 2, 4, and you have another vector 4, 8. So these vectors, what kind of property these vectors share?
Twice of this.
Yeah, that means
Twice.
yeah. Twice of this.
Dependent, linearly dependent.
Yeah, that means linearly
vector.
dependent.
Dependent.
So this is first vector and this is the second vector. This is just twice of this. So I can write, let's say this is v1 and this is v2. So I'm taking two vectors only in this particular set, because 3-dimensional it will be difficult for me to visualize. So let's go for 2-dimensional case only. So I can write v1 is 2 of v2. That means v1 minus 2 v2 is equals to 0. However, we have already argued that these coefficients itself will be 0. Only then we can say that this set is linearly independent. Over here, first coefficient is 1, second coefficient is -2. That means this set is linearly dependent. And any collinear vectors are linearly dependent. Linearly dependent. Now you can check that, for example, this particular case, option A, you do x1 plus x2, you will get this particular vector. That means x1 plus x2 is x3. So option A is linearly dependent. Similarly, in case of option B, you can write x2 plus 2 into x1, and then you can get x3. That means again there is a relation. The coefficients are non-zero. So over there you will get another dependent set. Only when you will use this particular operation, option C, then you will get the final result. And I have seen that in the solution that is basically given by the NPTEL side, they have written something like that: determinant of x1, x2, x3 for option C, it is not equal to 0. Then you can say that option C is the correct answer. And why is it so? Like determinant, from where on earth determinant came? Anybody has any answer for that? In the solution, if you check the solution given by the NPTEL, they have written another condition along with this condition that I have told, x1 plus x2 equal to x3, and this condition, they have written another condition that option C obeys this rule, and that is why your vector is linearly what you call linearly independent. Can anybody tell me what is the reason?
Is that the matrix way of solving this question? Same question?
Yeah, you can. Yeah, using this particular operation, you are solving it using a matrix based method. But why this determinant of all these components will be not equal to 0 on that represents that the set is linearly independent? This comes from a mathematical proof. But the question is why determinant should be not equal to 0? What is the meaning of determinant first? Physically, we need to understand to get down to the solution. For example, you have a vector. Let's say 3, 0 and 0, 2. You plot these two vectors in the two-dimensional space. So 3, 0 will be over here and 2, 0 will be over here. Means 0, 2 will be over here. And as per the vector rules, I can draw an imaginary vector of same height and length, and over here I can draw the same as per the rules of the vector. Now you calculate the area. Area is how much? 3 into 2, 6. Now you take this determinant of this particular matrix is how much? 6. That means if this is x1 and this is x2 vector, so determinant of these two vectors will give you the area enclosed by this vectors. Yes, area. Now, okay. Okay, now let us consider a linearly dependent case, as we already have seen one. So this is a linearly dependent case. So over here, what will be the area enclosed by these two graphs, these two vectors?
0.
0. That means
0.
the determinant of those vectors, if it is
Linearly
0,
independent.
that means they are dependent. And the other way around, determinant A not equal to 0 refers to the independent case. So that is why if you check the determinant of all these options, only option C will satisfy the result. So this is the way you should actually observe the questions. Just not try to solve the questions to get the numerical results, because in case of machine learning, as we are dealing with machine learning and deep learning, so already I have told that in this particular case, over here, feature extraction will be very difficult. In many places, the feature will look alike. For example, you are doing similar operation over here. For example, this is class 1 and this is class 2. For both the classes, you are extracting some feature and both the features are aligned with each other. Now, can you say that using these similar features, your machine learning or deep learning model will be able to classify well? Will it perform well or will it give degraded results? Yes, anyone?
It won't be able to classify properly, sir.
Yes, so it won't able to classify. That means in case of machine learning and deep learning, the feature extraction process, in case of machine learning, mostly the feature extraction process should be such that there should be no dependency in the features. For example, if class 1, the feature is like this, and for class 2, feature is also like this, aligned with each other, then your machine learning model will be confused. Okay, class 1 feature looks like this and class 2 feature is also similar to this. That means the feature that you are extracting, that is not good. So that is why in case of machine learning, we always say that you have to extract very good handcrafted features. And if you do not know that what is that good handcrafted feature, you will extract n number of features, you will use n number of features to classify to get the particular class, and your model will show the degraded results because the features are very alike with each other, and hence your model will not be able to classify the given images or given features. So this is why whatever linear algebra will be doing, try to visualize the problem, not just try to solve the problem to get the final answer, because these questions are meant to put in a such manner that they have some physical meaning out of that. Try to extract these physical meanings. Okay. Next question, if we go, for example, 3 equations are given and z equals to 2 is also given. So let's just plug z equals to 2. So x plus 2y is equals to 3. And over here it is minus 2x. Sorry, it is minus 4y. And this will be 4 and it will go over there. So it will be minus 6. So it is x plus 2y is equals to 3 again. So when the system of linear equation, or let's say you have 2 lines, when the lines have a unique solution, for example, this is a line, this is another line, line 1 and line 2. When these line 1 and line 2 will have unique solution graphically,
when they will intersect each
yeah,
other.
yeah, when they will intersect each other. And currently what is happening is that you are just scaling this particular equation by a factor of -2. If you incorporate -2 factor over there, so it will be -2 into 3. That means you are on the same line. So this is x plus 2y, and you are just scaling that particular line with a scaling factor. So that means you will have n number of solutions that they are lying in the uh, they are actually lying on that particular pathway. So over there you will get any n number of solutions. So z equal to 2 is the obvious solution, as because it is given, and in terms of x and y you will get infinite number of x and y solutions. Okay. And the last question is to find the eigenvalues. So theoretically, eigenvalues are also highly important as far as machine learning and deep learning is concerned, because the physical phenomena associated with the eigenvalue is very important as you go on learning these particular deep learning and machine learning concepts. So a minus lambda I, and you take determinant, will be equal to 0. So 5 minus lambda, 4, minus 3, minus 2 minus lambda is equals to 0. Then the characteristic equation will be 5 minus lambda, minus 2 minus lambda. Then it will be plus 12. So it will be lambda squared minus 3 lambda plus 2. And it will get down to lambda equal to 2 comma 1, which is over here. So this is the eigenvalues, and eigenvectors are those vectors. What is the equation for eigenvector? Can anyone tell me? To evaluate any eigenvalue or eigenvector, what is the basic fundamental law? If a matrix A is there and it has a eigenvector x, then ax will be lambda into x. Can anybody infer any physical phenomena out of that, but this particular equation? Because the equation looks very simple. However, it contains several physical information. So what is this A is actually called? What is the name of this matrix?
This is scalar multiplication of eigenvector. This AX, right?
Yeah, this particular side basically means the scalar multiplication of the eigenvector. And A is basically rotation. A gives rotation. For example, you have a vector, this. Let's say I have written the values so that I can just give you that problem. Let me just search the values. Okay, let's say you have a vector A, vector V, and you multiply. So your vector V is, let's say, -4 and 3, and A is what? 5, 4, -3, -2. Now, if you multiply these two, you will see, let's say you consider it 4. 4 only, 4 and 3. If you multiply this, you will see that the result of multiplication will go somewhere over here. That means initially the vector was here. Now the vector position has been changed. That means it is giving some kind of rotation into the system. So it is giving some kind of rotation. Now, this equation tells that even if you multiply with A, multiply A with this particular vector, the output will be the same vector multiplied with a scalar. That means in this particular case, you have a vector, you multiply with A, it will not rotate. This time what will do? It will either enlarge if lambda is greater than 1. Otherwise, it will shorten down if lambda is less than 1. That means there will be no rotation factor. So this is very important. In PCA lecture, probably in week 6 or something, you will see that these eigenvalues play a very key important role, because any vector can destroy your information. For example, if you incorporate any rotation vector and you have extracted some features, if you multiply these two, your information will totally distort. Initially you are somewhere over here. Now you are getting at this particular location. So your feature has already changed. However, you need to choose some sort of rotation such that even if you multiply with this, you are not rotating. That means you are actually staying on the same line. Maybe the line has been scaled up or scaled down, but your direction has not been changed. So you will see the application. So this is the mathematical interpretation of this particular sort. So A is basically a rotation matrix. So different sort of rotation matrices are there. For example, cos theta 0, 0 sin theta. So this is a sort of rotation matrix. So you can explore these things by yourself. So as far as the boundary descriptors has been taught in the class, so can anybody give me that what is the boundary descriptor for this particular elliptical shape? Boundary description from the centroid. From the centroid, we'll have a vector, and then we'll rotate that vector over the whole circumference, sorry, and then we'll plot the distribution, that how the distance is basically changing with each point in the circumference. So can anybody tell me that? Let us consider we start from 0 degree, 0 degree, 90 degree, 180, and likewise is 270 and 360 at this particular point. So what will be the shape of the boundary descriptor? Can anybody tell me?
It will be a straight line.
This is the ellipse.
Not
triangular.
not
It will go.
Normal curve.
No.
It will be large, and then at 90 degree it will be down, and that pattern should repeat.
Okay, so
like a starting.
yeah, this
Polygon.
no, not polygon. So the way of solving. So
Sinusoidal
previously,
or maybe
no,
sinusoidal.
so let us start visiting the points from 0 degree. At 0 degree, what will be the length of
It
the
should be like
vector?
a triangular.
Not triangular, because the values will be gradually
cos
first
function.
slow down. No,
Cos.
not cos. So initially at 0 degree, what is the distance from centroid? A, right?
Maximum.
Maxima. Now you go like this till you reach 90 degree. You get a minima, that is of height how much b. At 90 degree the value is how much b. Then you again go, someone's mic is on, please turn it off. Then again you go like this, that means again your length is increasing. So at when you reach
It will
180 degree,
repeating till 360.
yeah, at 180 degree again you will get a maxima, right? At 270
Yes.
again
It will be
at
minimum base.
minima, and again at
B.
360 you will get a maxima of a, and these minimas are of b value, right? I hope there is no confusion. If you find any confusion, you can ask. Okay, it seems no confusion is there. So I would ask you to try this particular case. So over here, the geometry is a rectangle. In the class, Professor PKB has solved for square. Now in this particular case, we'll be actually focusing on rectangle. So what will be the structure of rectangle? Because in this case, the boundary descriptor, evaluating the boundary descriptor is quite tricky. So first start with at point at 0 degree. 0 degree, then at 45 degree, or let's say, let me not rename it as 45 or something. Let's say theta when you reach the diagonal, then at 90 over here, and likewise. So at 0 degree, what is the length of the vector? Anyone?
I by 2.
Maximum I will do.
So
L
the
by
values
L
are
by
given. L,
L
yeah,
by
yeah,
two.
L by 2. Yes, L by 2, L by 2. Because
Oh,
this
sorry,
is
sorry.
half of the, this is the length is given L. So this is half of the L. So over here at 0 degree, you are at L by 2.
L by 2.
Okay. Now at theta, this theta is how much? Can anyone?
45.
45 degree.
45.
Yeah, 45. So let's just not no, actually I can show you. This is how much? L by 2, and this is how much? H by 2, right? H by 2. So tan theta is equals to how much? H by 2 divided by L by 2, that is H by L. So tan theta is equals to H by L. So theta equals to tan inverse H by L. So now can you say whether this is 45 degree in case of rectangle?
Oh, no. It should be in a square.
It should,
No, sir. No, sir.
yeah.
Square.
That is why in case of rectangle, the evaluation technique is quite tricky, because many of the people initially will write, because it seems that it is 45 degree. So you many of the people will write 45 degree and then they will evaluate. So here is the first tricky point, that theta, at theta where you get the diagonal, the location is this one, tan inverse H by L. Tan inverse H by L. And what will be the length of the vector? Can anybody? What will be the length of the vector?
AC square is equal to Pythagoras theorem.
Yeah. So Pythagoras theorem, you will get root under L squared plus H squared divided by 2. So you will get a maxima. and obviously this is maxima because Pythagoras theorem. So you are reaching to maximum. Now let's say by this you go to till 90 degree. Over here this is 90 degree. So at 90 degree, what is the value of the vector?
h/2.
Yeah, this is h/2. So over here it will be h/2 at 90 degree. Okay. Now again you go at that, but at this particular side, gradually it will increase. And over here, now tell me what is the location? Yeah, it will be maximum. I need you to answer that what is the value of the theta over here?
$180.
No, not 180. I am asking that what is the value of the theta?
180 minus 10 inverse h by L.
10 inverse L by H.
10 inverse H.
10 inverse L by H. Why? Because over here this is L upon 2. Over here this is H upon 2. So if you do tan theta, it will be tan theta. It will be L by 2, H by 2. So it will be L upon H. So over here, the maxima will again come at tan inverse L by H. And then again at 180 degree, what will be the vector's length at 180 degree?
L.
L by 2. L by 2.
L by 2.
So this is the structure. So let me go to the next page and draw it clearly. So the structure looks like at 0, at tan inverse. So let me see what was there.
H by 2. H by L.
Yeah. So tan inverse H by L. Then you got 90 degree.
90 degree.
Then tan inverse L by H and 180 degree. So I am drawing
180.
till 180. So I think you have got how to evaluate the values. So you can evaluate till 360. I hope you can do that, because that is pretty easy. At 180 degree, the whatever pattern is there, it will just be replicated. So this is H by 2. So initially you will get a maxima. Then at 90 degree, you will get a minima of H by 2, and then again you reach maxima at tan inverse L by H, and then again a local minima, because the global minima is H by 2. So sorry, it is at 180. Okay. So this is like this. Okay, so there are two minimas. One is this one, L by 2, and one is H by 2.
H by 2.
So these types of problems are called this is called a local minima. Local minima. And this is the global minima. Global minima means that the extremum lowest case. So this is global minima. And you will see that in case of deep learning, as you go on, this finding local minima and global minima becomes very difficult problem to minimize when you try to minimize the loss function. So anyway,
I have a question here. Actually,
yes,
not related to this topic actually.
Yes.
So in deep learning, like we are optimizing the loss function, right? For example, it is not a univariate or bivariate problem. So the dimension would be very high. So if the dimension is exceeding three dimensions, so the curve, the function of the loss function is very difficult to like visualize. And how we are able to find out whether the loss that we have obtained to optimization is the global minima. Is there any possibility to get local minimum?
Actually, this discussion will go into details of deep learning, but I will give you a fairly quick answer to that. So in deep learning, often, let me try to visualize in a 3D space. So it is difficult, but let me try. So let's say you have a space like this, and over here also a space like this. So let us consider here lies a local minima. Okay, and here lies the global minima, as because the value is low over here, and over here the value is low, but it is not lower than the global one. So this is the global. In case of deep learning, as you rightly said, in case of deep learning, if the equation is in 2 dimension, for example, in this particular case, you can fairly see the global minimum. Or if it is still something like this, this is the global minimum. You can visualize the problem, but the problem becomes very difficult as because you are trying to minimize the loss function with n number of weight variables. That means n number of this dimensionality instead of 3, it will blow up to, if a model contains 10 million parameter, that means the dimensionality will be 10 million dimension will be there. And visualizing these problems are typically very difficult. And finding a global minima there, it's a very challenging process, NP-hard problem. So in many cases, you will be stuck at local minima. And there is till date, there is no finite process exist. Any standard, at least any standard process doesn't exist, which will ensure that you are at global minimum. Your model basically learns the features in such a way it may stuck at local at any particular local minima such that it performs optimally. If you reach global minima, then your model will be absolutely very much fine. However, that means your model will give you 100% accuracy. But in case of, if you are trapped in a local minima, then your model will perform suboptimally. For example, 90% accuracy. There are some methods. For example, it is in week probably 10 or something. There are some process. For example, momentum optimizer. Then you have AdaGrad, by which Adam AdaGrad, by which so by which you try to get to this position by iterating over some hyperparameters, but still they do not guarantee that you will end up to the global minimum, because that is a NP-hard problem. Because from every direction you are trying to minimize the gradient. For example, this is a structure. In this particular area, the gradient or nabla operator, and this particular area, the gradient, the derivative is quite smooth because changes are very less. Over here, suddenly there is very high change. That means gradient is very high. So your model will first, what it will do? It will go over here, then it will straight away jump to this particular location. But at this side, as the variation is very less, in the next iteration, it will go over here. And however, your global minima lies over here, global minima. And now, as because your downward gradient is very high, you are moving away from the global minima. So now this is the problem, that this is global minima, but you are running away from the global minima due to the structure of the function, structure of the loss function. So momentum optimizer, AdaGrad optimizer tries to adaptively जैसे कि at this particular point you are not going beyond this momentum optimizer. What it will do, it will put a extra push in this direction such that you reach to this global minima quickly. But it tries, but in many cases you there is no certain statement is there that you end up to a global minima. As far as new papers are there, I haven't found any, but you can check other papers if in recent years they have found any solution. But till date it is a NP hard problem.
Okay, got it. Thank you very much.
Okay. So over here,
Sir,
yes.
sir, so how in a corporate world this problem can be solved? How the corporate workers can solve this problem?
How the
Corporate persons or corporate employees solve this problem?
uh, I don't understand. Corporate employees
Sir,
problem.
my question is that, sir, you drop this a biggest limitation of this problem. So, how the employees solve this problem? How they feel it? How they
Okay. That
tackle it?
means, yeah. So one way is actually the deep learning area. It is very broad. So many people are trying. For example, this all these things are coming from any research paper. So this moment people are trying to modify these optimizers. For example, momentum optimizer is there, but they are trying to incorporate some other terms such that you try to reach to the global minima as fast as possible. But the problem is, for example, I am doing a two class problem, and the structure of the loss function is quite like this. And let's say someone is doing some problem even more challenging. You are having this much of curvature, and there you are trying to find the global minima over there. So people are trying to modify these particular existing optimizers, or trying to what you call propose their own optimizers such that they can reach to a global minima. But obviously any research paper will have certain limitations. At some point of time they have to restrict their uh, work at some point. That means people are trying, even though people are trying to impose some criteria on the adagrad, adam, etc., and it is still a research problem. People are still trying to solve this particular question. If you see Amazon and Google and Deep Brain, so they are still trying to, in recent ICLR conferences there, ICLR and CVPR. These are standard deep learning machine learning conferences. They have recently proposed a paper over there which says that they have got some decent amount of accuracy in getting to global minima, but still that is a problem centric approach, because the approach that they are following for their task may not give me the same result in my particular task. So still this is a research problem. People are trying to do many sorts of simulation and then try to get to idea. Okay. So this is another question related to the descriptors. So this is a gray level co-occurrence descriptor. So this is GLCM. So you have been given a patch of image. This is a patch. That means you have a very big image, for example 224 cross 224, and from this 224 cross 224 you have been taken one patch out, and this is the patch. And you need to evaluate a GLCM matrix out of it, or the gray level co-occurrence matrix, or the basic vanilla co-occurrence matrix. So a co-occurrence matrix A is the co-occurrence of I comma j, this is the pixel values, with a parameter L comma theta. That means this is distance between pixel, and theta is the orientation of the pixel. Orientation of pixel, as it is already discussed in the class. So over here, we need to find A of all possible sorts ij, and the parameter has been given 1, 1. And they have written what does 1, 1 mean. 1, 1, it has interpretation 1 pixel to the right and 1 pixel below. So first tell me what will be the size of the GLCM matrix from this image patch. What will be the GLCM? 3 cross 3.
3 by 3.
Yeah. So 0, 1, 2, 0, 1, 2, as because the pixel value ranges from 0 to 2. So tell me A0, 0, 1, 1, A0, 0. So what will be the count?
1.
Sir, how to decide it is 3 cross 3?
Okay. So to decide it, first we need to check what is the maximum and minimum pixel value. Maximum pixel value is what? 2. Minimum pixel value is 0. So there are total 3 variations, 1, 0, 1, 2. So that means there is a range of 3 values. So the matrix size will be 3 cross 3. Okay. So over here, the orientation has been given in such a way that 1 pixel to the right, 1 pixel to the below. So we need to check 1 pixel to the right, 1 pixel to the below, and then the diagonal pixel will check whether they are forming any pair or not. So over here, we are finding 0, 0 pairs. So 0, 0 pairs with this sort. Can anybody locate where is 0, 0 pair with this sort? Anyone?
Third and fourth row.
Third and fourth row, 0, 1, 2. Third and fourth row. So you are referring to this one.
This diagonal one.
This diagonal one. Okay, but let's say your point of consideration is this 2. So you go to right, then go to below. Are they forming any pair? No. In case of these zeros, this is not possible because you cannot go to this side. You can go to this side, but you cannot go up because they have written 1 pixel below. Got my point?
Yes, sir.
Okay, so over here, I think I cannot see any possibilities. 0, 0 is not there. 0, 0 is not there. Over here also. Okay, so 0, 0 is 0. So let us find A22 with same parameter. Can anyone tell me how many A22s are there? I can see one.
2.
Likewise, I can see another one. So this is another one.
There is range of 2, 2.
6.
4 plus 6.
6.
7, 1. 7.
How can you locate with the number of with row and column where it is?
No, there is
So
nothing.
in the mid of first row.
First row.
I think 7.
Mid. So these two you are referring.
And the diagonal in the below.
So you are referring to this one, right? You are referring to this one.
Yes.
But this is not. You cannot do this one because
sir, what is the meaning of that 1 pixel to right and 1 pixel below? How to identify?
Okay. So for a point of consideration, let us consider this is our point of consideration 0. Now, if I consider this point, I will go to right 1 pixel right, I will go below 1 pixel below from this point. And then I will check whether the pairing is forming or not. If the pairing is forming over here, then I will write that okay, there exists a pair, co-occurrence is there. For example,
That
if
means
my
you have to
point,
check pair between 0, 1 and 2.
yeah, for example, if I am talking about 8 to 2, so let us consider I will start from here. So 2 is there, I will go one right, I will go one below. Then I will check, okay, another 2 is there. So they are forming a pair. So this is the first one. Second one, let's say, let's
Start
check over
with
here.
0, move right and then down.
Yeah. So over here again, you start with this 2, go over here, then go down. Okay, another 2 is there. So they are forming a pair. So +1. Any other formation is there? I think there is no formation is there. So this is 2. So can anyone, this is the last one. So you can fill this whole matrix by yourself. So A11 with 1 1 parameter. Can anyone show any
Yes, sir.
pair
So
have?
there is one.
First row, second.
Yes, sir.
First row,
Diagonally
second.
just first and
Yeah.
second.
Yes.
Yes,
First and
yes.
second.
And anything else is there?
No, nothing else.
Okay.
No, sir.
So this
No.
is 1, this is 2. So in this way, you need to fill this whole matrix. Got it?
So Fourier descriptor, can you explain, sir?
Okay, so Fourier descriptors, for example,
About the coefficient,
yeah.
lower coefficient, truncated coefficient.
Yeah. For example, this is a square wave. So I think all might know what is Fourier transform and what is Fourier series. So let's say you have a square wave. What Fourier actually tells is that if you add infinite number of sine waves or cosine waves, you start with low frequency, you keep on increasing the frequencies, infinite number of such sine or cosine wave, and you add all them, then you will get a shape like this. So any shape you can decompose using certain sinusoids or cosinusoids with varying frequency. So in case of this particular shape, you can see that initial frequencies are low frequency. You go on this down the line, the frequency increases. That means now let us consider you do Fourier transform. You get this many subcomponents, and if you add all these subcomponents, you will get a structure like this. Now let's say you do the reconstruction. Let's say you have been given n number of such sinusoids, and let's say you are trying to reconstruct this particular shape, and you are using first and second signal. So obviously you will not get a sharp square like this. You will get something like this. Okay, you keep on increasing the addition, then you might get something like this. You keep on increasing till n till let's say 30. Then you will see that you are getting some kind of square wave, but still it is not purely square.
Sir,
Let
it
us
could be
consider
asymptotic.
it could be asymptotic means
Means this would not be square, but sometimes will look like square, but this is not square. Like this.
That means when you are adding these coefficients or these signals or these half bands, you may not get the exact shape until and unless you add all the components. Let's say you are getting, after Fourier transformation, you are getting 50 components. So you are getting 1 to 50, 50 number of such signals. Now let's say you are adding 1 to 30. Matlab, means starting from 1 to 30 components you are adding. So you will get something like square, but not exactly square that you have.
Yes, yes.
Yeah, something like this. But if you add 1 to 50, all of them, so then only
That
you
could be
will get
square.
a, then you will get a sharp square like
Lower
this.
frequency give a smooth curve, sir.
Yeah,
It means
yeah. Lower
smooth curve.
frequency gives smooth and higher frequency gives detail. Detail means in signal processing, detail means high frequency. High frequency.
Fix. Okay.
Or in image processing, they call it edge. Edge features. That means at this particular location, you can see now there is a sharp transition is there. So we call it in image processing, we call it edge. So Fourier descriptors, initial Fourier descriptors will give you smoothing information, and down the line they will give you the detail information or edge information or high frequency information.
Thanks, sir.
Okay, so this is a very easy example, easy question. So you have two classes, omega 1 and omega 2, and you have a feature vector. And if you choose to be the feature vector belongs to omega 1, x belongs to omega 1 using minimum error classifier. So your probability of the a posteriori probability of omega 1 will be greater than omega 2, right? And if x belongs to omega 1, so what will be the condition then? If the feature belongs to omega 2, then what will be the condition?
Omega 2 greater than omega 1.
Yeah, so omega 2 given x greater than omega 1 given x. So over here, let's check omega 1. If x given omega 1, because this is the class conditional probability from, I think at this point of time, who is joining? Okay, at on option A, we have class conditional probabilities. Class conditional probability, they don't have any any relation with finding the final probability to get to the to map it to a particular class, because it is the a posteriori probability which tells you that at which particular class the sample will belong to. So option A is incorrect, as because these probabilities are class conditional probabilities. Then you have omega 1 when the prior probabilities have been given. So prior probabilities also, this is not correct. Choose omega 2 if omega 1 is greater than omega 2. So that means it is also wrong. Choose omega 1 when p of omega 1, a posteriori probability of omega 1 is greater than the a posteriori probability of omega 2. So option D is the correct answer.
I have a doubt. Actually, do
Yeah.
you use any negative log likelihood for optimization over here?
Negative log likelihood for what?
So for a Bayes classifier, this is a Bayes classifier, right? Nice Bayes classifier kind of log. So here the optimization function would be negative log likelihood, right?
We have not even reached to that point when we'll be talking about negative log likelihood. Actually, these are very simple, very preliminary level classifiers where optimization is not used.
So
If you
minimum
see the
error in terms what it defines, like here what we are defining.
yeah, let me tell you. I have given this example. For example,
Okay.
you are classifying into two classes. Let me give
Yes,
you,
yes.
let me show you in this page. Okay, so let's say you are classifying into two classes, and these are the a posteriori probability. That means p
Yeah.
of omega 2 given x, and this is p of omega 1 given x.
Yes.
At the test time, I'm saying you have trained your model, and at the test time, this x, let's say x is coming over here. From the test set, you extract a feature X and the feature is coming over here. At this particular point, the probability of getting classified at omega 1 is this one,
Yes.
here to here.
Yes.
And probability of getting classified to class omega 2 is over here. So
Yeah.
whichever is higher, we'll map it to that particular class. That means X belongs to omega 1 as P omega 1 X is greater than P omega 2 X. Now, total probability is what? Total probability of this part. Someone is joining. I don't know at this point. Okay, total probability will be P of omega 1 given X plus P of omega 2 given X, because there is some finite probability that it may belong to class omega 2, which is over here, the shorter one, and total probability is equal to 1. So the correct probability, for belonging to class omega 1 is P of omega 1 given X, right? Which is why we are actually predicting it to class omega 1. So error is what? Error is total probability minus correct probability. That means 1 minus P of omega 1 given X. So 1 minus P of omega 1 given X means P of omega 2 given X. Is it not? So this is the error.
Okay.
So even
So this
though
is
I
my
am
error
saying
in finding the
this,
probability of
finding the
W1.
probability of the sample that belongs to class omega 1.
Yeah, got it.
But okay.
Yeah, thank you.
Sir, one question on the co-occurrence matrix.
Yeah. Yes.
What is the, how do we calculate the maximum probability descriptor there?
Maximum probability descriptor there. Okay. So max Cij. We define it with this particular term, max Cij. So max Cij is basically over here. What is the highest value? Let us consider we are values. Let's say I'm not writing the exact values. Let us consider this is again 0. This is 1. This is 0, 1, 0, 1. Let us fill this whole matrix with some arbitrary values. So what is the highest value over here? 2.
2.
And how many total pixel points we are having over here in this particular matrix?
9.
1, 2,
Some of
3,
them
4, 5. No. How in total matrix? How many sample points we are having? 5 cross 5.
25.
Yes.
25. So 2 upon 25.
Okay.
That is max Cij. So this normalizing factor, that is what I have written 25. It may vary. In the question, if they are asking, for example, this 25, this is you are normalizing the values. If you see in any Python or MATLAB code, they ask you that whether you want your GLCM matrix to be normalized or not. And there are some normalizing criteria. For example, instead of writing 25 over here, you could have normalized using all the values, summation of all the values over here. So for example, it would be 2 divided by 1, 2, 3, 4 and 6, 2 by 6. So this normalizing factor may change, but it will be maximum value in the GLCM matrix, max of GLCM dividing by normalizing factor. So this normalizing factor, you can declare it by yourself. You can normalize with any particular value.
Thank you.
Generally people do it with the patch size. Whatever patch size is given, you you divide it with that patch size. But it is up to you what to do with that. How to normalize, you can do it by yourself. Okay.
Like, this is like a convolution layer, right? Like patch you are mentioning it as convolution layer.
Actually, I'm using patch because this particular problem that I have taken, it was written in such a way. For example, you have a 2 to 4 cross 2 to 4 matrix image, image of this big dimension.
Yes, yes.
And let us consider you have 0 to 255 pixel values. So your GLCM matrix would be 256 cross 256. So in a mathematically, as far as problem solving is concerned, I cannot draw a 256 cross 256 image. So what they have done from this whole image, they have taken a 5 cross 5 patch. And this is the patch. And for this particular patch, you have been asked to find a GLCM. So that is why I am using patch word. I know in CNN they use patch, but we are not focusing on those. We are not inferring that patch. So from this whole image, we are taking a snip out of it. So this is that particular snip. Okay. So over here, the question is, yeah, over here the question is, we have been given a minimum risk classifier. And these are the probability values. These are the class conditional probabilities. And these are the prior probabilities. You have been given a loss matrix or penalty matrix. Already we have discussed what is loss matrix, penalty matrix. So if classifier X aligns to omega 1, that means X is omega 1, then what will be the condition? So if X omega 1 means in case of minimum risk classifier, what will be the condition? Risk alpha 1 X and risk alpha 2 X.
Alpha 1 W.
Which will be maximum in between these two? R alpha 1 X. You are saying this will be maximum.
Alpha 1x.
Alpha 1x.
Alpha 1 will be minimum, right?
Minimum, yes. Because we are trying to minimize the risk.
Alpha 1.
Yeah, we are trying to minimize the risk. So if I choose alpha 1, that means it belongs to class omega 1 and we are trying to do so. Therefore, the risk should be minimum. Okay. So for this particular case, already we have derived the equation. So let me just write down the equation for you. So this will be P of omega 1 given X divided by P of omega 2 given X, which will be greater than what is given lambda 1 2 minus lambda 2 2 lambda 2 1 minus lambda 1 1. As already I have previously derived this particular equation, so I am not going for the derivation again. So P of omega 1 given X. So a posteriori probability we don't know, we have to evaluate. So a posteriori probability will be how much? P of omega 1 multiplied with P of X given omega 1 divided by P of omega 2 multiplied with P of X given omega 2, right? So this is lambda 1 2, lambda 2 2, lambda 2 1 and lambda 1 1. So can anybody just evaluate all these values? What is the value is coming for this part? If you have, I think you can calculate in mobile also. Can anybody tell me what was the value?
1.5. 1.5.
1.5. So 0. omega 1 के लिए है 0.2 multiplied with 0.75 divided by
1.50.
0.05. So it is coming 1.50. It is coming 1.50. So 0.2 multiplied with 0.75 divided by 0.8, 0.4. So it is coming actually 0.37.
This is 0.375.
Yeah. So this is 0.375. So 0.375 is greater than lambda 12, lambda 22, lambda 21, lambda 11. So it is not matching with any of the conditions. So let me just inverse it. So lambda 21 minus lambda 11 divided by lambda 12 minus lambda 22 is greater than 1 divided by 0.375, and which is actually
2.67.
2.67. So the option D is the right answer. Okay. So in the next class, in the next live session, we have solved week 0 quiz and practice questions for week 1, right? So in the next week, I will try to do the hands-on session of week 1 content. For example, the feature extraction, for example, GLCM extraction, then what you call Fourier descriptors, Gabor filters, all those things we'll do in the next class. Along with that, so there is another very unique feature people use in image processing, which is used for machine learning, deep learning application. For example, we have evaluated a matrix called GLCM matrix. There is another pattern that is called a local binary pattern, and how to evaluate that. For example, we have a image and we are focusing a patch at this particular location where the central patch refers to 7, right? So in case of local binary pattern, what we'll do, we will start from this location and we will rotate till the last point. We'll start from 10, then we'll rotate to 6. So a total of 8 values will be there, 1, 2, 3, 4, 5, 6, 7, 8. And we'll put a condition that if the value at current position is greater than the central value, we'll replace with 1. And if it is less than the central value, we'll replace with 0. So let me show you one instance. So this is 10. So 10 is greater than 7. So 1. 12 is greater than 7. 1. 9 is greater than 19, 16, 10. And for here 7 is equal to 7. At that condition also we will put 1. So over here 1 again. And this is 6. So 6 is less than 7. So over here we are putting 0. So this is a 8-bit pattern, 8-bit binary pattern. So from a patch of 9 cross 9 elements, you are getting a 8-bit binary pattern. Now let's
Please,
say
one time more. How to write?
Okay. So you take a patch. For example, we have taken a 3 cross 3 patch. So there is a center value 7. Now around the center value, there how many neighbors are there of 7? How many neighbors are there? 7 is 8 neighbors are there. So we will search for those 8 neighbor positions. That means we'll start from 10, 12, 9, 16, 19. Like this way, we can traverse from this point to 6 and we'll get total 8 values. And we have a condition that if this value is greater than the central value, we will replace it with 1. And if it is less than the central value, then we'll replace it with 0. Let us start from this particular position, from 10. So at this particular location, 10 is greater than 7. So I have replaced it with 1. Over here, 12 is greater than 7. So over here, I have written 1. Similarly, 9 is greater than 7. So 1. In this way, let us consider at this particular location 6. So 6 is less than 7. That means it will be 0. Got it?
Thanks, sir.
Okay. So given this 3x3 patch, you are getting a 8-bit binary pattern. Okay, you are getting a 8-bit binary pattern. And let's just rotate this particular image. So you rotate
Sir, that
it by
sequence also matter.
Yes, the sequence matters. I will show you why the sequence matters and what is the peculiar thing happens if we just stick to this particular pattern. So let us consider we keep the same image, we rotate it with some angle, for example, an angle of theta. So we have rotated this particular image with an angle of theta. So all these values which is around this 7 will also be rotated. For example, it will be shifted to this particular position. 12 will be shifted to this particular position. So that is what happened. 10 is shifted over here. 12 is shifted over here. Now again, you try to generate a 8-bit binary pattern. So now you will start from this location and you will traverse like this and end up to this particular location, right? So over here, initially 6 is less than 0, so 0. In all other cases, it is higher or equal to the central value, so 1, 1, 1, 1, 1. So if your equivalent decimal point is 254, initially we have a binary pattern and this is the decimal representation. And over here also, this is the decimal representation. So what is the peculiar thing that has happened? We have kept the same image. My pixel location, my pixel central pixel is same. Now I have a central pixel of 7. Now we have just rotated this particular image. Now image is same, central pixel is same. Just this just with this change of these positions of these neighbors, you are getting some different value, which is quite significantly different. Initially you are getting 254. Now you are getting 127. It is totally different. Now if your features gets changed with some distortion, for example, you have given a alpha, given a theta rotation, that means you have distorted the image. That means given us very small distortion, if your feature changes drastically from this to this, then this is not a very good feature because your feature is not robust. For example, if 254 was referring to a car, how can you say that 127, that's a huge gap, will refer to the same, will infer to the same image? That means this feature set of the vanilla 8-bit pattern is not quite robust. So for this, the local binary pattern came. So they ensured that given this local binary pattern, you will do a circular shift, a left-sided circular shift. That means you will circularly shift this 0 point one by one. So over here in the first shift, there is 0 and all the values are 1, and this one is the last trailing one, so it will go at this particular location. So as there are total 8 bits, so how many circular shifts will be there? You have 8 bits, so how many circular shifts you can do?
8.
7.
8 actually.
Okay.
So you start from this. Where is the pen? 1, 2, 3, 4, 5, 6, 7. And you consider this final operation is also a circular shifted output. So you will have a total number of 8 circular shifts. So over here, you are getting doing this particular circular shift, you can see that this 254 automatically converges to 127. That means these bit patterns, if you just change these bit patterns, you will get a relation in between all these combinations. That means 254 by the circular shift operations will refer to this final value, that is 127. That means now your feature extraction process, as because you yourself are doing circular shifts and you are tracking all the values, that if I rotate this with first shift, with second shift, third shift, that how the values are changing, you can see that you have collected all possible sort of rotation outputs. That means you have generated a robust set of rotation outputs, and these rotation outputs will refer to the same image, as because you have done the processing in such a manner. So this collection of these values will give you a local binary pattern. And even in some cases you will see that minimum of all these p, let us consider this is pi. People also consider this as the local binary pattern. So given any patch, you will do the first binary, you will go for a 8-bit binary pattern, then you will do a circular shift, and whatever minimum value is yielding, that we will consider for a particular one search value. So in this way, you will get all the possible rotation operations. For example, if you had rotated it in this direction, you are getting this particular value. If you had rotated in this direction, you are getting this particular value. So in this way, you are from a single patch, you are getting multiple number of feature values, which will effectively help in classifying. For example, I think PKV sir has told that in the challenges of deep learning, that if you see a single Taj Mahal image from different view angles, from front it looks something like what we usually see. If you see from the side, so the image will change, image property will change, but still it is Taj Mahal. That means in those conditions, how to classify with good features, local binary pattern basically helps in those cases where the images are kind of rotated or occluded. So for those conditions, local binary patterns are used along with the texture information, along with the GLCM matrix and all. Local binary pattern is also a quite frequently used feature for image processing. And you can get the information from this particular deep learning for visual computing. This is also another NPTEL course, so you can refer to this lecture also. So here you will get the information about how the binary local pattern is basically computed. So you can take the minimum value from this whole set to refer to a binary local binary pattern. So in the next session, we'll focus on just solving the practice questions of week 2 and then directly jump to our coding session. And likewise, I will do in the later live sessions also. So if you have any further questions, you can ask.
We do image augmentation, right?
Yeah.
If the data set is very less.
Yeah. Yes.
So like the patterns that we are getting it from different images, right? Like even though it belongs to the same class, if you are doing some image augmentation, then my pixel values will change according to the rotation, right? From patches that we are taking. So these concepts are applied over there in this case.
Actually, I think you are basically referring to deep learning based solution. Is it?
Yes, deep learning.
So in case of deep learning, you don't have to worry about these binary patterns and all, because deep learning models, the main difference between machine learning and deep learning is deep learning itself tries to learn features, very well features. Now I am talking this one is basically used in, I think probably 1987 or something. Okay, so that time deep learning was not there. People what tried to do is, you have an image, you rotate it. Now they checked whether your model is able to classify it or not. So then people saw that no, their model is not able to classify. That means their model is very much sensitive with the rotation operation. So what they tried to search for, they tried to search for a robust set of features which is rotation invariant. That means when you rotate a signal, you get all these possible values, which will say that even if this is rotated, I have some entry for that particular rotation, and that entry will guide you that even though it is rotated, it is card only. But in case of deep learning, you don't have to think about it. You will do n number of augmentation, rotation at 90 degree, 180 degree, whatever you do, you feed all these images to the model. The deep learning network itself is highly intelligent that it will be able to understand, okay, all these images belong to card only. However, in case of machine learning, that is not possible. So people search for various feature extraction process. So that is the history of this particular feature.
Yeah, thank you.
Yeah, so any other question? Okay, so yeah,
Thank you.
someone has raised their hand. Yes, Bodugala Ramamurthy. So, do you have any question, Mr. Ramamurthy? I hope mistakenly by mistake he has raised hand. Okay, it seems that there is no further question, so we can stop the lecture over here. And I will be uploading this lecture in my YouTube channel. Just search by my name. You will get the video probably by tomorrow morning. And as well as I will be uploading these sheet, this whole slide that I have solved over here. I will be uploading it also in my G drive. So the links will be shared. Otherwise, what you can do, I am giving the link of my website. So in my website, you will get all the materials. So let me just share the my website. So from the website itself, you can actually visit to the YouTube channel and you can actually get all the resources. And there is a tab called teaching. So in the teaching also, I will give the links. So in the teaching tab, you will access all the materials that is there. And along with that, from the next week, as I will be doing the Python codings, so all those Python codes also I will upload in my GitHub profile. So from there also you can download all the codes and do and run the codes at your own site. And we'll be using Google Colab platform, so you don't have to worry about installing Anaconda or Python into the system. So on the web itself, Google provides a very handy platform on which you can actually run your Python codes. So we'll be using that. So at any machine, the all the deep learning codes will run. So you don't have to go for a high computing computer or laptop. So it is not required. Google Colab itself, it is highly efficient. It will do all the computations for you.
Sir, one query.
Yeah,
If suppose if there is further clarifications, should we put it in the forum or is there any mail ID so that we can contact you?
Okay, so it is advised to us that participants will be posting the questions in the forum itself. So we'll be answering those questions in the forum. Otherwise, I have already shared my website. In my website, all my details, that email IDs and all are given. So if you have any further queries, you can personally mail also. But it is recommended that you actually post your questions in the forum. So if you see the forum currently, for example, I think you can see my screen. So ask question, you go to ask question. And over here, you can see that people have raised questions. So from here also you can get my mail ID because I frequently answer the questions as well.
Okay, sir.
Okay. Okay, so I think we can stop the recording then.
Thank you very much, sir.
Okay.
Thank you so much.
Thank you, sir. It was a good session.
Thank you, sir, for your time.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Good night, everyone. Okay.
Good night, sir.
Good night.
Have a very happy evening.
Good night.
Good night, sir.